Hello, Algebra 2 friends. This is the Chapter 4 practice test, and I am going to be going through the problems with you today. So number 1, we are asked to multiply 5x squared times 2x squared plus x minus 6. This is just going to be the distributive property because we're multiplying a monomial times a trinomial. 5x squared times 2x squared is going to give us 10x to the fourth. 5x squared times positive x is going to give us positive 5x cubed. And 5x squared times negative 6 is going to give us negative 30x squared. And then when I look at my three terms, none of them are like terms, so there's nothing to combine here. So this is going to be my final answer. In example 2, I'm multiplying a binomial times a binomial. This process we call FOIL. But remember, FOIL is really just the distributive property twice. Because really what we're doing when we're FOILing, first times first, is we're taking the 5x times the x, which is 5x squared. And then our outers means we're taking the 5x times the 3, which is going to give us 15x. Our inners, we are taking negative 1 times x, which is negative 1x. And then our lasts, we are taking negative 1 times positive 3, which gives us negative 3. And then we do have like terms. The negative 1x and the positive 15x we can combine together. So that's going to give us a final answer of 5x squared plus 14x minus 3. In example 3, we want to make sure that we realize that this squared out here on the outside of the parentheses means that we have 2 of the families of 3x minus 2. So our first job in number 3 is going to be to expand 3x minus 2 times 3x minus 2. Now we FOIL. First, outer, inner, last, or distributive property twice. So 3x times 3x gives us 9x squared. 3x times negative 2 is negative 6x. Negative 2 times 3x is another negative 6x. And negative 2 times negative 2 is positive 4. And then when we combine our like terms, we get 9x squared minus 12x plus 4. In example 4, we are multiplying a binomial times a trinomial. So this really is distributive property twice. So the first thing I'm going to do is I'm going to multiply the 2x all the way across the trinomial. 2x times 3x squared is going to give me 6x cubed. 2x times negative x is going to be negative 2x squared. 2x times positive 4 is positive 8x. Then I'm going to take the negative 1 and I'm going to multiply that times the 3 terms in the trinomial. Negative 1 times 3x squared makes negative 3x squared. I'm going to make it easier on myself in the next step, and I'm going to write it underneath the other x squared term. Negative 1 times negative x, negative times negative makes positive, so that will be positive 1x. I'm going to write that under the x term. And then negative 1 times positive 4 makes negative 4. And now the last step in this problem is to combine like terms for my final answer. I have a 6x cubed. Then I have two x squared terms. Negative 2 plus negative 3 makes negative 5x squared. I have two x terms. 8x plus 1x makes 9x. And then I have a negative 4 constant term. So here's my final answer for problem number 4. Then we move on to factoring. We're going to start here with our 4-term polynomials, and we know that 4 terms means that we do factoring by grouping. So when I factor by grouping, I'm going to group the first 2 terms and the second 2 terms, and I am looking for the greatest common factor that I can take out of both pairs. In x cubed and x squared, the greatest common factor would be x squared that I can take from both. So if I put the x squared on the outside, what I have left in the first term would be x to the first power. What I have left in the second term would just be a positive 1, because remember, when you distribute the x squared back, you need to get back to where you started. X squared times x is x cubed, x squared times 1 is x squared. Now that I have factored the first pair, I know that every time I factor by grouping, my parentheses have to match. So that means that my second parenthesis, has to be x plus 1. So then I just have to figure out the number that goes in the front. Something times x has to make negative 2x. Well, that would be a negative 2. And then if I check that, negative 2 times positive 1 makes a negative 2. So then I know that negative 2 is the correct GCF for the second pair. So now to finish off the factoring by grouping, remember we take our two GCFs and those become the first binomial, x squared minus 2. The second binomial is the x plus 1. And remember that you can always check your answer by FOIL. If you FOIL this, you should get back to the 4 terms that we started with. Example 8 is another factoring by grouping problem. I'm going to do it the same way. The GCF for my first 2 terms, they're both even, 2 and 10, so I know I can take a 2 out of both. And then the first term is x to the 6th, and the second term is x to the 4th, so I know I can take out x to the 4th. So my GCF for this pair of terms is going to be 2x to the 4th. And then what I have left in the first term, I already took out the 2 and 4 x's, so I'll have x squared left. And then in the second term, I already took out the x to the 4th, and I divided negative 10 by 2, so I'm going to have negative 5 left. So then, assuming I did that correctly, my second parenthesis is going to be x squared minus 5. So now to figure out the number that goes in front, I'm thinking about what would I multiply x squared by to make 3x squared? And the answer would be a positive 3. And then I check, is 3 times negative 5 equal to negative 15? Yes, it is. So then I know that I have the correct GCF. So I can go ahead and write my 2 binomials, 2x to the 4th plus 3 and x squared minus 5. And that is my final factored solution. In the next 4 problems, these are trinomials, 3 terms, and note that A is 1. So we do not need to split the middle or slide and divide. Now, can you do those methods? Of course, they always work, but you don't need to do them when A is 1 because we know that if the first term in the trinomial is x squared, that has to come from x and x. So then we just have to figure out the 2 numbers that multiply to make a positive 4 because that's our C term. And if that's a positive, the 2 numbers have to have the same sign. They have to be both positive or both negative. Well, if I look at my middle term, which is also positive 4, that's the number I want them to add to make. Remember, this is the number I want them to multiply to make. I'm looking for 2 positives. Figure out your signs first. So then I know that positive 4 I could get from multiplying 1 times 4 or 2 times 2. But if I want them to add to be a positive 4, then it has to be 2 and 2, and both of them are going to be positive. So I can just fill my parenthesis in with positive 2 and positive 2, and I am done. And again, check by FOIL if you're not sure. In number 10, the number that I want them to multiply to make is negative 36. And I know that when 2 numbers multiply to make a negative, one of them must be positive and one of them must be negative. If you consult your white factor sheet, the ways to make 36 would be 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. Those are my possible pairs. I'm looking for a pair that adds to make 16. And remember, I need one of them to be positive and one of them to be negative. So really, I'm looking for a pair that is 16 numbers apart. Well, when you find that, it is 2 and 18. And if I want a positive 16, I know the 18 has to be positive and the 2 has to be negative. So then I end up with x minus 2 times x plus 18. In number 11, I am looking for a pair of numbers that multiplies to make positive 20, so same sign, and adds to make negative 9, so both negatives. Ways to make 20 are 1 times 20, 2 times 10, and 4 times 5. I want them to add to make a negative 9. So it has to be the negative 4, negative 5. So I write x minus 4, x minus 5, and factoring complete. Finally, number 12. I want my two numbers to multiply to make negative 24, so a plus minus pair again because it's a negative. And ways to make 24. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. And I want my pair to add to make a negative 5. So the pair that is 5 numbers apart is 3 and 8. And if I want a negative 5, that means the 8 has to be negative and the 3 has to be positive. So I write x plus 3 and x minus 8. And factoring complete. In the next examples, note that now a is greater than 1. So this is where I have to do a little bit more work to get my factors because it's not just going to be x and x for my first terms. There's going to be a coefficient on at least one of them, maybe both of them. So this is where you would either do slide and divide or split the middle, or if you like guess and check, you could do guess and check. I'll do a variety here just so that we can get some practice. On the first one, I will do split the middle. So my first step is going to be to multiply 3 times 10, which is going to make positive 30. And if two numbers multiply to make a positive, they have the same sign. I want them to add to make a positive 17, so I know that means they will both be positive. Ways to make 30 are 1 times 30, 2 times 15, 3 times 10, and 5 times 6. I need a positive 17, and I need them both to be positive. So that means it has to be 2 and 15. So now if I'm going to split the middle, I'm going to rewrite the 17x as positive 2x and positive 15x. I'm going to bring down the 3x squared, and I'm going to bring down the positive 10. And now I am going to factor by grouping. 4 terms. The GCF for the first pair is just x. So if I take out the x, then what I have left is going to be 3x in the first term and positive 2 in the second term. And I know with factoring by grouping, my parentheses have to match. So my second parenthesis also has to be 3x plus 2. So now I just have to figure out the GCF in the front of the parenthesis. Something times 3x makes 15x. Well, that has to be a positive 5. And 5 times 2 is 10, so I know that that's correct. So now I put my two GCFs together. One of my binomials is x plus 5, and the other binomial is 3x plus 2. Factoring complete. And remember, you can check by FOIL. On the second example, I am going to do split the middle. Again, if you prefer slide and divide, we should still have the same answer when we're done. So when I when I do slide and divide, the first thing I do is multiply a times c. 5 times negative 4 is negative 20. I'm going to circle my 5 so I don't forget to divide by it later, but then I'm going to write this as x squared plus 19x minus 20. And now I am looking for a pair of numbers, positive and negative, because it's a negative 20, that multiply to make negative 20 and add to make positive 19. Well, there's 1 and 20, there's 2 and 10, and there's 4 and 5. And if I want a positive 19, that means it has to be 1 and 20. And if I want it to be positive 19, it has to be a positive 20 and a negative 1. So I write x plus 20 and x minus 1, but then don't forget the divide step in slide and divide. So now I'm going to divide by 5 on both of these. In the first binomial, 20 divided by 5 is 4, so that becomes x plus 4. In the second binomial, I cannot reduce 1 over 5, and I can't divide that into a whole number, so then that 5 swings up and becomes a coefficient of the x. So 5x minus 1 is my second binomial. So you should have the same answer as I do regardless of method. All right, the next section is our special polynomials. So these are the difference of squares, the sum of cubes, or the difference of cubes. So first we have to figure out what is it, and then once we know what it is, we can use our blue sheet to fill in the parentheses for the factors. So when I look at number 3, I have x squared minus 81. So this is a difference. And my two terms in this case are both perfect squares because it's x squared and it's 81. So I know that this is a DOS, right? And I know off my blue sheet that difference of squares, which look like a squared minus b squared, factor into a plus b, a minus b. So I need to figure out what is a and what is b. Well, in the first term, x is being squared to make x squared. And in the second term, 9 is being squared to make 81. So now I know my a and I know my b. A is x and b is 9. So then I just go ahead, I write my two sets of parentheses, and I know the first one's going to be a plus b, so x plus 9. And the second one's going to be a minus b, so x minus 9. And I am done. Number 4, I have 16x squared again, and then 49. So again, if I have an x squared, the only thing it could be is a difference of squares, because otherwise it would be cubed if it was a cube. So again, difference of squares. The first term is a perfect square, and the second term is a perfect square. Excuse me. So I just need to figure out my a and my b so that I can fill in my parentheses. The term that is being squared to make 16x squared is going to be 4x times 4x. The term that is being squared to make 49 is going to be 7. So now I've got my a and my b. 4x is a and 7 is b. I draw my two sets of parentheses, and it's 4x plus 7 and 4x minus 7. And that's it. All right, number 5, I see x cubed, and I see a plus sign, and I know that 512 is 8 cubed, so this is a sum of cubes. Okay, and remember the sum of cubes factoring pattern off your blue sheet. This factors into a plus b, a squared minus ab plus b squared. Okay, so we just need to figure out a and b, and then we can get this done. So let's see, x is being cubed to make x cubed, and 8 is being cubed to make 512. So I'm going to write my parentheses for my binomial and then my bigger parenthesis for my trinomial. And the first one is going to be a plus b, right? And x is a and 8 is b. So it's going to be x plus 8 in my first parenthesis. And then my second parenthesis starts with my a term squared. A is just x, so x times x is x squared. Then I have a minus sign. Then I have to multiply a times b. X times 8 is 8x. Then I have a plus sign, And then I have to take b times b. Well, b is 8, so 8 times 8 is 64. And remember that the trinomial that we get when we factor a sum or a difference of cubes is always prime, so that is done. Okay, number 6. I see an x cubed, so this must be another cubed. And it's a plus sign again, so it's another sum of cubes. Same factoring pattern as number 5. So I just need to figure out my a and my b. So let's see. To make 729x cubed, 9 cubed is 729, so that's going to be 9 and x. 9x times 9x times 9x would make 729x cubed. And then 64 would be 4 cubed. All right, so I know my a and my b, and it is the same factoring pattern that I already have written down because it's another sum of cubes. So I just have to put a plus b in my first parenthesis, so that is going to be 9x plus 4. And then the second parenthesis, remember, starts with a squared. This is that bear trap that I keep talking about. When we square our a term, which is 9x, remember, that's not going to be 9x squared. That's going to be 9x times 9x, which is 81x squared. Then we have a minus, and then a times b, 9x times 4 is 36x, plus, and then our b term squared, 4 times 4 is 16. So this is the answer for number 6. All right, our last problems are the putting it all together. So it says, note, all problems will require multiple factoring techniques. So keep in mind, the blue sheet guides you through this process, but really we need to start every single problem that we do by looking for a greatest common factor first. And if there is one, after we take it out, then we figure out what to do next. But step 1 is always GCF first. All right, so let's take a look at number 7. And there is a GCF on number 7, 6, 24, and 72. I can divide all of those terms by 6. Since the 72 doesn't have a variable, I can't take an x out, but I can take a 6 out of everything, okay? So my GCF is just 6. So I write 6. And then my first term is just going to have an x squared left. My second term is going to become negative 4x. And my third term is going to become negative 12. Okay, so now I need to factor x squared minus 4x minus 12. So I've got a trinomial for my step 2, but a is 1. So I do not have to split the middle or slide and divide. I just have to find the pair that multiplies to make negative 12, so I know it will be a plus minus pair. I've got 1 and 12, 2 and 6, or 3 and 4. And I want them to add to make a negative 4 in the middle. So I'm going to get that from the 2 and the 6, because those are 4 numbers apart. And if I want a negative 4, my 6 has to be negative and my 2 has to be positive. So I just go ahead and I write x plus 2 times x minus 6. But then we can't forget that in our answer, we have to put that GCF in the front because that is part of our factoring. So my final answer is 6 times x plus 2 times x minus 6. All right, number 8, we are going to start the exact same way. GCF first. And looking at those 3 terms, I definitely see a GCF. 6, 9, and 3 can all be divided by 3. I also see that they all have x's. Since 3x squared has the least number of x's, I can only take out an x squared. So my GCF, my step 1 here, GCF, is going to be 3x squared. All right, so then my first term is going to have left a 2x squared. 2 times 3 is 6. X squared times x squared is x to the 4th. My second term is going to be a 3x. 3x times 3x squared would be 9x cubed. And then if 3x squared was my GCF, then that third term is just going to be a positive 1. Don't forget, we always have to have something there. All right, so now my step 2 is to factor what's inside the parentheses. And what I have inside of my parentheses is a trinomial. And this time, a is greater than 1, right? A is 2. So this is where I need to split the middle or slide and divide or guess and check, right? And this one is actually an awesome guess and check problem because 2x squared has to be 2x and x, and the only way to make positive 1 is 1 and 1, and they have to have the same sign, so it's either positive 1, or negative 1, negative 1. Well, if the middle term is positive, they're both going to be positives. So I kind of already figured it out. So for this one, I am going to guess and check, okay? 2x squared is going to be 2x and x. And to make a positive 1, it's got to be either negative 1 times negative 1 or positive 1 times positive 1. And if the positive 3 is in the middle, then I know it has to be a positive and a positive. And I can do a quick check of my inners and my outers. I have a positive 2x and a positive 1x, which adds to make that positive 3x, so I know that that's correct. So writing my final answer here, I'm going to have a 3x squared, a 2x plus 1, and an x plus 1. And that one is done. All right, number 9. I only have 2 terms, but I should still look for a GCF first. And what I see is, well, 2 and 128 are both even, so for sure I can take out a 2. They also both have x's, so I can take 1x out since 128x has only 1x. So my GCF will be 2x. What will be left in my first term will be x cubed. What will be left in my second term will be positive 64. All right, now I have to factor x cubed plus 64, which is a sum of cubes. So now I am going to use my blue sheet. I know that something cubed makes x cubed. Well, that's going to be x. So there's my A. And I know something cubed makes 64. Well, that's 4. So there's my B. And I know my factoring pattern is going to be A plus B, A squared minus AB plus B squared, right? I just have to fill that in. So my binomial will be x plus 4, and then my trinomial will be x squared minus 4x plus 4 times 4 is 16. And then don't forget the 2x GCF from the beginning of the problem goes in front of your answer. All right, last one, number 10. I see a GCF, 7x squared minus 28. My GCF is going to be 7. So if I factor out a 7, then I'm just going to have x squared minus 4. All right, then my second step is I need to factor x squared minus 4. Well, that, 2 terms, minus sign, so it's a difference. And I have x squared, which is a square. So this is a difference of squares. Okay, what is being squared to make x squared? That's an x. What is being squared to make 4? That's a 2. So I know my A and I know my B. So now I just have to do A plus B, A minus B, right? That's the factoring pattern for a difference of squares. So this is going to be x plus 2, x minus 2, and then don't forget GCF of 7 goes in the front of your answer. And that's it, friends. So hopefully you feel ready for our Chapter 4 test tomorrow.